is Dr. Esther Trufan, and in today's experiment, I am going to demonstrate how to do a recrystallization of cream of tartar. For this, we're going to need potassium bitartrate, or cream of tartar, and we're going to use water, because there is a substantial difference between the solubility of cream of tartar at room temperature and its solubility at the boiling point of water. It is a very suitable approach for the recrystallization of cream of tartar. Because we're going to take advantage of temperature differences, it is important that we use a hot plate to heat our water. I have a hot plate here. We're going to turn this on and then hike its temperature. We want to be above the boiling point of water, which is 100 degrees Celsius. Some heat is always lost to the environment, so I am setting it to 113 degrees. Next, I'm going to use a relatively large 600 milliliter beaker because I need to know the mass of the cream of tartar that I'm putting inside. I will use a scale, and I will need to know the volume of the ionized water that I'm using for the experiment. I'm going to use a 100 milliliter graduated cylinder. First, I'm going to turn on my scale, place my beaker on top, tare it, and when it shows 0.00, I am ready to add 18 grams of cream of tartar. We can be a little over or a little under, but we should not exceed 18.3 grams. I have 18.15 grams of cream of tartar. This is pretty good. I can set my scale to the side, and I am ready to add my water. First, I measure out 100 milliliters. I want to be just under the 100 milliliter mark, 99.2 milliliters. I add another 100 milliliter increment. And again, I want to stop just under the marking. If it's a little too much, I can always extract it. The meniscus of my water is exactly at the 100.0 mark. I will pour this over. And then I will measure a third 100 milliliter amount. It is quite close at 99.8 milliliters. I will pour this into my large beaker. And we can swirl it around a little bit, but we can see our mixture is extremely cloudy. And that is normal because cream of tartar is quite insoluble at room temperature. That will change when the temperature goes up to the boiling point of water. So we take our beaker with the cream of tartar mixture, and then we begin heating our hot plate. And hopefully, as it gets to the boiling point of water, it is going to dissolve all of it and our mixture will turn clear. With more vigorous stirring and heating, the temperature of our mixture is increasing, and we can already see that the cream of tartar that was on the bottom of the beaker is not quite there anymore. And while we do see lots of small particles floating around, it looks a little bit more clear than it was before. It has been some time since we started warming and stirring the cream of tartar inside the ionized water, and we can see that the mixture is starting to clear up. There is still a little bit of fine powder on the bottom, but as long as the mixture is boiling, that should dissolve and the mixture should clear up, forming a clear solution. Unless there have been some additives in our container, at which point the clarity will not be achieved. So we want to make sure that the solution comes to a vigorous boil. If at that point it is completely clear, we just set it aside and let it cool slowly. The slower, the better. However, if when it's boiling and it has boiled for at least 10 or more minutes and clarity still has not been achieved, that means that there have been additives in our container and we need to do a very fast filtration, which means that our only option at that point will be Buchner filtration that needs to be accomplished in as little time as possible with the boiling hot liquid. But with this mixture, we can already see that clarity is slowly getting achieved, and what we see on the bottom are more combinations of bubbles that are coming from the boiling and a little bit of powder still moving around. So we're going to keep it going for just a couple more minutes, and then we're going to make a decision for this. Our solution with the cream of tartar is clearing up. The solution is boiling, so that is pretty great. And when we look at it, there's barely anything on the bottom, but if we give it 1 or 2 more minutes, it will completely clear up. If this is not your experience when you're boiling this solution, then you need to do that hot filtration. But if your solution cleared up like this, it is fantastic. That means that the cream of tartar from your container was pure, and from there you can proceed with the crystallization. Because there is such a large difference in the solubility of cream of tartar at the boiling temperature of the water and at room temperature when dissolved in water, once we take it off the hot plate, it will very quickly produce crystals. Even if you just lower the temperature by a little bit, it will start producing precipitate or crystalline material. So that is why it is so important that you keep your cream of tartar in water boiling for at least some time before you draw any conclusions about the purity of the material. Now that all our material is fully dissolved, our solution is clear, I can simply turn down the temperature. And as I turn down the temperature, we may already start seeing crystallization. But if that doesn't happen very quickly, we can just put it on some kind of surface that is insulated to make sure that our benchtop does not get burnt, or that we don't accidentally place it on top of a water droplet, causing our beaker to shatter, and then we need to restart our experiment. Very slowly let it cool down. The slower the better, because that improves the quality of your crystals. If the cooling happens over the course of 24 hours or even longer, that's better, and you should expect to see beautiful, shiny crystals forming. Our solution has been cooling for some time, and this is after 24 hours. We heated it up, it turned into a clear solution, then we cooled it down because the solution was clear. If the solution was not clear, then we need to do a hot filtration really, really fast, and that means we're going to use Buchner filtration. After it cooled down, we have a lot more options. You can see that the solution is rather clear, and on the bottom, there are really nice looking crystals. We don't really care about how they look, but we do care that when they are crystalline, they are more pure than they were in their powder forms. So we're going to do a filtration. Here you may do a Buchner filtration or a gravity filtration. Today I am going to demonstrate the gravity filtration. For this, you're going to need a stand with an O-ring, and inside that O-ring, you're going to place a funnel. Make sure the O-ring is the right size to support your funnel. Under the funnel, there should be an Erlenmeyer. This will catch your filtrate, and ideally, the stem of the funnel should be just under the rim of your container. If you don't have an Erlenmeyer, you may use other containers. Because we're doing a filtration, we're also going to use filter paper. I will use a large filter paper, and I will fold it as usual in half, create a crease, and then in half again, and this way I have neat quarters. I will create another crease. Then I will open it in such a way, not in half. So on one side I have 1 layer of the filter paper, and on the other side I have 3 layers. This will give me a nice cone shape. If I place this cone shape into my funnel and just let go, it will jump out at me. So the next thing that I'm going to do is add just a couple drops of my solution into my filter paper. This way, when the filter paper is wet, it sticks to the sides of my funnel. And now we can begin filtration. I will add plenty of solution to my funnel. And because the top is rather clear solution, it will go through rather quickly. If we find that this is a little higher than we prefer, we can lower it a little bit more. Because we're working with a large volume of solution, we want to keep the top layer as clear as possible to help with the speed of the filtration. And then when we get closer to the bottom, we're going to swirl it a little bit more vigorously to get all the crystals into our funnel. When we're pouring solution into the funnel, the important thing is not to exceed the rim of the funnel, otherwise it is going to spill out on the sides. Once our solution is mostly transferred and our crystals are still hanging out at the bottom of our large beaker, it is time for a little bit more intensity as we pour things over. So we want to swirl our contents and then very quickly transfer it over. If something spills, that's okay. The majority of our content is in the crystals and the crystals may be collected. If we're still struggling with the transfer of our contents, we can always employ the help of a spatula and scrape everything inside. We are close to done, but not quite. It is always a good idea when we're doing recrystallization and then filtering off our filtrate to rinse our crystals with small amounts of deionized water. So we add small increments into our beaker. Make sure that we are swirling vigorously so that our crystals are moving around, and then rather quickly transfer them into our funnel. We'll do this at least one more time to rinse our beaker completely and transfer all the crystals. If we need to, we can do it a third time. Swirling vigorously and then very quickly transferring so that our crystals stay kind of floating around a little bit. And then finally, we add at least 1 or 2 small increments of water onto our filter paper to make sure that all our solution is washed both from around the crystals and from the filter paper. Then one more time with a small increment. And from there, we let it drip until all our solution goes through and only the crystals are left at the top. Now for these crystals, because they are rather temperature sensitive, I do not recommend that we put them on a hot plate and dry them as other materials. It is best to take these, place them on a watch glass or a small container, and let them air dry over the next couple of days. It has been about 24 hours since I left my crystals of cream of tartar to dry on the filter paper. Remember, I don't want to heat this because it will undergo some decomposition processes. So for now, I'm just going to leave it as is, in air dry, so it is as dry as it can be. And next, I am going to weigh it, and then I'm going to put it in a container for later use. I'm bringing in my scale, and I am going to bring in my container. I am going to turn on my scale, compare it, and when it shows 0.00, I will place my filter paper with the cream of tartar crystals on the top. I will record my mass, which is 19.32 grams. At that point, I will open my container, transfer all the crystals of cream of tartar into it, and then weigh my empty filter paper. The mass of my filter paper is 2.72 grams. The difference between the two measurements is going to be the mass of my cream of tartar. And now that I have pure cream of tartar crystals, I am ready to take on experiments then we'll require pure cream of tartar to produce a different product.